This is the video for the second lesson of week 1. We're still graphing sine and cosine equations, but now we're going to focus on the periods. Now the periods are going to start changing, okay? So let's just jump right into this. Again, I just did this is the second lesson. I did the first lesson an hour ago, so it's probably not going to be much better, so I apologize. But let's look at the equation y equals sine of bx. So now I've thrown in this extra variable here. We're also going to be looking at cosine of bx. Now, all of these work, or this is how all of the different trig functions work, the other 4 as well, and we'll take a look at those on a later date. Yesterday, or in the last video, we talked about the a, and we know that the absolute value of a is the amplitude. And the amplitude is just your period. If my amplitude is, let's say, 3, from the middle of my graph, I'm going to go up 3 and down 3 to get to those mins and maxes. And then the distance from the very top to the very bottom of my graph would be 6, okay? Let's say my amplitude is 1/2. I'm going to go up 1/2 and down 1/2 from the middle of my graph, so the distance from the top to the bottom would only be 1 unit. Okay, so then now we've added this b, and b is a coefficient in front of the variable, okay, a coefficient in front of the variable. It's going to affect the period. Now, very important, the period is equal to 2 pi over b. So that is important. All right, so let's see if I can draw a box. The answer is probably no. Yep, that would be no. All right, so here we go. Let's look at the basic sine curve that we started with yesterday and just kind of verify that it is 1, or that it is 2 pi. Okay, so we looked at y equals sine of x yesterday, and when we graphed it, we said it's going to start at the origin, it's going to go up, down, and it's going to end, and that's what one full period would look like, and then after that it's just going to keep repeating itself, and we said that that was going to happen at 2 pi, okay, at 2 pi. Let me turn that off. Okay, so using the period formula, well, that tells me that I'm going to take 2 pi and divide it by b. Our b in this equation, there is no number in front of the x, so remember, it's an understood 1, so the period is 2 pi. So that just kind of is your justification to show you how to find the period. All right, so let's move on to a different equation. So let's go down here. All right. So let's look at, I'm going to go f of theta equals, and there we go again. We're just going to leave that, cosine of 3 theta. And I am going to graph this from, let's say, 0 to 3 pi. Okay, we're going to graph that from 0 to 3 pi. So I'm just going to get my graph ready. That do not like that. So let's try it again. All right. So let me turn this off because I don't like it. My amplitude is 1. That comes from right here. That means I'm only going to go up 1 and down 1 from the middle, okay? And I'm just going to go 2 tick marks. That way it's not smushed together in that little area. Now, my period. Remember, period is 2 pi divided by b. So I'm going to take 2 pi and divide that by 3. Now, unfortunately, that does not reduce, so there's our period. So it's not as nice as we would like it to be, but it will work. Now, a little tip when you're numbering this x-axis is look at these numbers. If I have a 3 there on the denominator, count by pi over 3's or count by pi over 6's, okay? Either one. Pi over 6 is going to maybe kind of stretch our graph a little bit this way. Or you could do pi over 3's. It does not matter. I'm just going to do pi over 3's. So if I count by pi over 3's, that would be pi over 3, 2 pi over 3. This would become 3 pi over 3, which is just pi. Okay? So then 3 more tick marks. This is going to become 2 pi. 3 more tick marks. This would become 3 pi. Okay? So a cosine graph, let me come over here. We talked about this in the last video. If I want to graph y equals cosine of x, I know that it starts at a maximum, comes down, ends at a maximum, and again, that's going to happen at 2 pi. So that right here is going to happen at every 2 pi over 3. So what I like to do, I think this helps me to do this, is I'm going to go every 2 pi over 3 and kind of put a gate. So if this is pi over 3, my first period is going to end right there. There's 2 pi over 3. I'm going to have this entire period happen right there. Okay, then I'm going to go another 2 pi over 3. There's another period. Okay, and another period. Whoops. And then another period. And then we're going to stop our graph at 3 pi. So we are going to have a little partial period right there. But total, we're going to have 1, 2, 3, 4 and a half periods. Okay, so this right here has to happen in between each one of these gates. So for cosine, again, we're going to start at a maximum. So over here, we're going to start at a maximum, and it's going to be 1 because my amplitude is 1. So my first point is going to be right here. Okay, let me change this. My period ends at a maximum, so right there. Now, in the middle of my cosine curve, I'm at a minimum. So the very middle of this is going to be down here. I'm going to have a minimum. Now, right in between my max and mins, I have intercepts on both sides. So right in between this box right here, right in the middle, I'm going to have intercepts. Now, if you're taking a pi over 3 and cutting it in half, this intercept will happen at pi over 6. Okay? This will happen at, let's see, this would be 1 pi over 6. This half would be 2 pi over 6, or pi over 3. So this is 3 pi over 6. Well, what's 3 over 6 going to reduce to? 1/2. So that ends up actually being pi over 2. And then that takes me to 4 pi over 6. This half would be 5 pi over 6 and 6 pi over 6. But I'm going to keep going. We're going to get sidetracked. Okay, so here's my first period. It's kind of steep. Again, try to make these curve. But I'm going to take this full period and I'm going to repeat that over and over and over. Okay, so in the middle of each period, I'm below. And then I'm back up here. Halfway, I'm at an intercept and an intercept. So I'm just going to keep on repeating that. Okay, now right here, this is a common mistake. Students will want to go right here. But what happens every half a box? We have an intercept. And then I'll go down. So there's your half a period. So there's what your graph is going to look like. Again, when we're talking about key features, I'm not going to go ahead and list all of them, but be very careful when you're counting because we're cutting these boxes in half. So I would go through and say pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, all the way. I know this would be 12 pi over 6. 13 pi over 6, 14, 15, 16, 17. This would have to be 18 pi over 6 because, again, 18 pi over 6 is 3 pi. Okay, so be careful when you're listing all those key features for the problems like these. Okay, now I do want to look at the calculator because we haven't talked about the calculator just yet. You do have to make sure, it shows right here, you're in radian mode. Okay, so when you go to your y equals, we'll type in our equation just like normal. Now, don't go graph it. We need to set up our window. We need to tell them what our x-axis needs to look like, what our y-axis needs to look like. Make it look just like the one we just graphed. So the one we just graphed, the x-axis started at 0, and we ended at 3 pi. So put 3 pi in there. Now, when I scroll down, it's going to change to a decimal. That's fine. Now, the x scale. What is each tick mark of pi over 3? So I'm going to put pi divided by 3. Now, on the y-axis, our graph only goes from -1 to 1. I just went a little bit further in either direction just so that we could make sure we could see everything. On those, it doesn't matter. But on the y scale, we are counting by 1, so make sure that's a 1. And then just hit graph, and there's what it looks like. Okay, so as it's graphing, there's pi over 3, there's 2 pi over 3, and you see that full period. Okay, so again, we've got 1, there's a period 2, 3, 4, and then there's our half where it ends at the very bottom at a minimum. Okay, so there's what your graph should look like. So make sure you are checking these in the calculator. Okay, so let's move on and let's do one more and we are finished for the week. Okay, and again, guys, if you're having any questions at all, let me know. I will post my notes on Oasis for this. If I have time, I'm going to try to find other videos for you to watch, or you can always go to YouTube and Google this stuff, anything that you think would help you. So the last one that I'm going to do with you, let's do a sine curve. Let's do y equals the sine of theta over 4. Okay, and I'm only going to graph this one. I'm going to go from 0 to 12 pi. So we're going a little farther on this one, and you're going to see why here in just a second. Your amplitude is still 1. Your period, okay, so remember, we're going to take 2 pi and divide it by b. Now, on this one, it is not 4. Your 4 is in the denominator. So in the numerator, there's a 1 there. So your b is 1/4. So I'm going to take 2 pi and I'm going to multiply it by the reciprocal, and 1 period is 8 pi. Now, we like these. When your period's bigger like that, this is going to make your graph a lot flatter. We're not going to have a bunch of twists and turns like we did up here. So these are actually a lot nicer to graph. Okay, so let's graph this one. Again, I only need to go up 1 and down 1 because my amplitude is 1. I do want to go to 12 pi, I said. So if I'm going to 12 pi, it doesn't matter. You can count by ones. That would work. Let's just do that. I'm going to make that, I'll just put 2 pi, and then that way I'm counting by one. I'm counting by pi's, but I'm only labeling every other one. So 8 pi right here, there's where we're going to see our 1 full period. So let me keep going here, 10 pi and 12 pi. Okay, so like I said, 1 period is 8 pi. So right here is where we're going to see this one period. Now, what I have left is 4 pi, so I'm going to see another half of a period in this area right here. Okay? Now, we know, what do we know? So I'm going to go look at what we did here. I'm going to do the same thing. I know, well, it would help if I fix that. I know that y equals sine of x is going to start at the origin, up, down, ends right there at 2 pi. So this is what a period looks like. That has to happen right here. Okay, so let me go get another color. Let's do orange. Our first point is going to be at the origin. Now, the period's going to end at the origin. And then right in the middle of your period, which would be 4 pi, you're back in the middle. Now, the first half of the graph, you're at a maximum. Now, our maximum needs to be at 1 because our amplitude is 1. So our minimum would be at -1. So that's going to happen at the halfway point there. So here's, that's ugly, what this is going to look like. Okay? And then I just need to repeat that. Eventually I'll get it. There we go. So now I just need to repeat that here. Okay? So if you look, I've got a point every 2 pi. So at 10 pi, I'm going to be back up here. And at 12 pi, I'm going to be back at the back at the x-axis. So there's my other half of a period. So that's what that graph would look like there. If I go check this in the calculator, let's do that really fast, and then I'm going to leave you guys. My calculator will pull up here. Okay, so if I go check this in the calculator, I've got the sine, where is it, of x divided by 4. We'll fix our window. We're going from 0 to now we are going to 12 pi. Our x scale, we're counting by pi's. And I'm just going to leave the y's alone. And I'm going to hit graph. And we should see that 1.5 pi. So right here, there's your full period. And there's your other half. And remember, I sent you guys a link to download one of these calculators on your Chromebook. That's something that Texas Instruments is doing for free because of the pandemic that's going on. So that is something that you should utilize if you don't have your good graphing calculator with you at home. That is available. So guys, week 1 is down. Again, email me with any questions. If we need to do another Google Meet or anything, we can. Until next week, I will see you guys later.